Hey boss, how are you today?
Unfortunately, I wish I was doing better than right now. You may want to check this video out.
Let's see.
Hello. I'm planning on destroying the world. In 31 hours, 41 minutes, and 59 seconds, a missile will be launched at the United States. Now, the only way to stop this missile is by solving 3 extremely difficult calculus problems. We all know, calculus is next to impossible.
Well, looks like we got a serious problem on our hands.
Yes, we do. But there's only one way we can fix that.
How is that?
You, Bambi, have to save the world.
How?
You have to seek out these rumors about this one man that lives in the Florida Keys that is the master of all calculus.
What do you want me to do?
Seek him and find him and learn his ways.
Right away.
What should we be looking
Whoa,
for?
jeez, whoa, don't sneak up on me like that, man. Who are you?
I, Mr. DX. Who do you call yourself?
Bambi.
Nice to meet you, Bambi, son. What are you looking for?
I'm looking for the master of calculus. Have you seen him?
Well, it depends. What you're looking for him for.
We need him to come back and save the world.
I'm sorry, I cannot go back anywhere. Who do you work for?
I work for the Homeland Security Department.
No. This does not work.
Why not?
They charge taxes to me. I no pay taxes.
Well, everyone's
in
got to
30
pay
years.
taxes.
No. Okay,
Is that why you moved to Florida?
that is why I moved to Florida. What else do you need?
Can you teach me the secrets of calculus? I need to save the world.
I suppose I can teach you the secrets of calculus. Do you have the commitment?
I do. I'll do whatever
Okay,
it takes.
follow me. Let's go inside.
Okay, Mr. DX, where do we start?
Where are you?
I'm right here with you.
How fast are you moving?
Pretty standstill at the moment.
How fast is your fastness changing?
What?
How fast is the rate at which your fastness is changing?
I don't even know idea what you're talking
The
about.
derivative of acceleration!
Whoa, no need to be a jerk about it.
Very well, Bambi, son. For your first lesson, walk towards the TV.
Okay.
Now, as you get close to the TV, what are you approaching?
I suppose the Xbox.
Yes. So, you see, as you approach the TV, the limit is the Xbox.
Okay.
Okay, now, move the Xbox over.
Alright.
Walk back towards me. Now turn around and retrace your steps.
Okay. Nothing here this time.
Yes, but are you not approaching the same place?
I suppose I am. I get it. So, even though the Xbox is disconnected from the function, I'm approaching the same point, so the limit remains the same.
Yes, very good. Now,
Okay.
move the Xbox back. Come back over here. Now, for a function to be continuous, all points must be connected. Now show this by tracing the function through the Xbox.
Okay.
Ah, yes. Now, show me the limit as you approach the refrigerator.
Alright.
Congratulations. It is now time to advance to the second stage of your training. For that, I will introduce you to my apprentice, Blackie-san.
You look familiar. Do I know you from somewhere?
I don't think so.
Okay. Must be weird.
Blackie-san, instruct Bambi-san in the arts of the derivative.
Let's get started.
Alright.
This is the definition of the derivative. This lets you find the rate of change of any function. The function can be known as the position. The derivative of that function can find the rate of change, or the velocity. The derivative of that is the acceleration, and the derivative of that is the jerk.
Sounds familiar.
Now, I know you're pressed on time, so here's a shortcut. If f of x equals kx to the n, and you try to take the derivative of that, you get n times k times x to the n minus 1. An example of that would be here, when you take f of x equals 3x to the third plus x squared. If you try to take the derivative of that, you get f prime of x equals 9x squared plus 2x. You try. If I give you the function 4x to the fourth, what's the derivative?
That would be 16x to the third, right?
That's correct. Let's move on. Sometimes you have to take the derivative of a composition of functions. To do that, you take the derivative of the outside of the function, then multiply it by the derivative of the inside of the function. In order to find the maximum, minimum, or concavity of a function, you must first take the derivative. If you set f prime of x equal to 0, then solve for x, you get the critical points. Taking the derivative of the derivative gives you the second derivative. You can use this to find concavity. For example, we found f double prime of x equals 2x of f prime of x. If you take the critical points, f double prime of 2, you get that equal to 4, which is concave up, which means it's a minimum. If you take f double prime of negative 2, you get that equal to negative 4, which is concave down, which means it's a maximum.
Bambison, the time for you to practice your knowledge of your derivatives has arrived. You may begin.
Now?
Now!
Okay, fine.
Now it is time that you are instructed in the art of the integral. The integral is defined as the area underneath the curve of a function. This can be very useful in different situations. Let's say you have a function that represents how fast you are traveling, and you want to know the total distance that you have traveled over a time period. The integral can help you with this.
Okay.
So, let's say that you are standing over there, and I know that you travel at a rate of 2 steps per second. In 2 seconds, you will be standing right there.
1, 2. Yep, you're right.
Now, Bambi-san, it is time for you to be instructed in your next lesson. Meet Joey-san, the master of the integral.
Shall we begin?
Ciao.
The fundamental theorem of calc states that f of x equals the derivative of the integral of f of x. To find the integral, we must use the antiderivative, which is the opposite of the derivative. Say if f of x equals 6x squared, the integral of 6x squared equals 2x to the third. Always remember plus c.
Okay.
Now say that our integral has bounds, 0 to 2. If our function is still 6x squared, it will equal 2x to the third evaluated at the bounds 0 and 2. To figure out our answer, we take 2 and plug in 2 for x, then minus 2 and plug in 0 for x again, and that will equal 16. Now we can solve for areas using integrals. Say we have the area between the curves f of x equals x squared minus 3 and g of x equals 2x. First we have to find the intersection points at 3 and negative 1. Then we take the integral from negative 1 to 3, and then we take 2x minus x squared minus 3 dx, and we get 32 over 3 for the area. We can also find volumes rotated around lines. Say we revolve y equals x squared around the x-axis from negative 2 to 2. We take our bounds, negative 2 and 2, and then we plug in pi x squared squared dx, and then we evaluate that, and we get that to equal 64 pi over 5.
You must also practice your knowledge of taking the integrals of equation.
Okay.
When you do this, remember, always, integral open, integral close, integral open, integral close.
I see.
Practice, here, go.
Integral open. Integral close.
It is now time for you to begin your final lesson. This lesson is solving a differential equation for a particular solution.
Alright.
I myself will be teaching you this final lesson. Are you ready to begin?
Ready as I'll ever be.
Let us go. When you have a particular solution to find, you are given dy over dx equals a certain equation. In this case, x times y. This differential equation models the rate of change for the function through point 1, 1. The first thing you must do is separate your variables. So you end up with dy over y equals x times dx. After that, you must integrate. Integrating 1 over y dy, that equals the integral of x dx. That gives you the natural log of y equals 1/2 x squared plus c. After that, the only thing you have left is to solve for both y and c. Simplifying the previous equation further, you get y equals ce to the 1/2 x squared. Plugging in your point 1, 1, you get 1 equals ce to the 1/2, then c equals 1 over radical e. Finally, you can plug in c into the particular solution and find that y equals e to the 1/2 x squared over radical e. Congratulations, Bambi-san. You have completed your training. Now, it is time for you to go back and save the world.
Including all of our butts.
Will do. Got it. Gotta get back. Can't give up. Gotta do it.
Oh God, Bambi, thank God you made it back.
Yeah,
We don't
what-
have much time left. You gotta go.
Alright, let's go.
What are you guys doing? We only have 45 minutes till the lunch. Get over here and look at this.
Oh gosh, what?
These were just faxed in right now. It's your job to solve them.
What kind of evil monster are we dealing with?
So I hear you ready for my problems. Good luck.
Bambi-san, use the calculus.
Bambi, what's wrong? You just switched off your graphing calculator.
It's okay, it's okay. I'm on the no calculator session now. Oh. I think I did it. Alright, here we go.
What? No! How could you have figured out those problems? They were impossible! Foiled again! No!
Yes! I did it! I saved everyone! For me, calculus was the way to save the world.